Now we're going to look at continuous exponential growth. So we're going to get away from the idea of decay and we're going to look at growth. So that means our exponent is now going to be positive. We're going to use the one on the right. Even though both of these really say the same thing, the one on the left deals more with money, whereas this one deals more with population growth. So let's look at this one. In 2007, the population of the state of Georgia was 9.36 million people. In 2000, it was 8.18 million. Determine the value of K, Georgia's relative rate of growth. So that means we're going to use y equals a e to the kt. K has to be positive. A, remember, is our initial value, and t is going to be time in years, k is your rate, and then y is whatever the population is after so long. So I'm going to take my scenario up here, and I'm going to write these as 2 points. In year 0, that's how I'm going to start. In year 0, we had 8.18 million people, because 2000 came before 2007. After 7 years, because from 2000 to 2007, 7 years have passed, my population was 9.36. Notice how I'm going from a smaller population to a bigger population as my years grow. Okay, so to plug some of this stuff in, remember A, we're going to write down each one of these in here. I'm going to go y equals a equals k equals and t equals. That way I know which ones I'm plugging in for. My question asks me to solve the value of k. So that means I don't know this one. A is your initial value, so this is your initial population. That is 8.18. In year 0, that's my population. After 7 years have passed, so my time is t, or time t is 7, I had 9.36 million people. And now we can plug in our stuff and find the value of k out of this. Okay, so 9.36 equals 8.18 e to the k times 7. This one's a little different. I do have an a value. Before I can take the natural log on both sides, I have to get this base e by itself. So I'm going to divide both sides by 8.18. I'm going to show the division without actually doing any of the division. So now I have this, and I'm going to rearrange. I'm going to put the number first before the variable. And now that you have the base e by itself, now you may take the natural log on both sides. So now I have natural log of 9.36 over 8.18 equals 7k natural log of e. Natural log of e, number is just 1, divide both sides by 7. Natural log of 9.36 over 8.18 divided by 7 equals k. You can plug that into your calculator. I'm going to do the same. Natural log of 9.36 divided by 8.18. Close it off, then divide by 7. It's going to get us a rate. We're going to use 4 decimal places when we do this. So k is going to be 0.0193. K is equal to 0.0, I already forgot, 193 for our population growth. Okay. We'll do part B as well. I'm going to actually write the equation now. So in terms of Georgia's population, we had y equals, our initial value is still 0.818 e to the, now I know my k, 0.0193 times t. Letter B asks, when will Georgia's population reach 12 million people? So if I'm asking when will, I want to solve for time t. 12 million goes in for y. 12 equals 8.18 e to the 0.0193 t. Very similar to part A. Divide both sides by 8.18. Oops. Equals e to the 0.0193 t. Now you may take your natural log on both sides. Natural log of 12 divided by 8.18 equals, exponent goes out in front. Natural log of e is just 1. Divide both sides by 0.0193. Natural log of 12 divided by 8.18 divided by my rate will get me my time. We can plug this into our calculator. Natural log of 12 divided by 8.18, close that off, divided by our rate, 0.0193. It's going to get us very close. We're going to round this up to about 20 years. And since it wants to know when will, they want to know what year out of this. Remember our initial year, this goes all the way back up here. Our initial year, year 0, was the year 2000. So from 20 years beyond that, we're talking about the year 2020.